All right, guys, here's another projectile motion problem. It says a projectile is launched from a 25-meter high cliff at an angle of 30 degrees above the horizontal. Find the following. I want initial vertical and horizontal components of the velocity. I want total time of flight. I want horizontal range. I want maximum height. And I want impact velocity. And it looks like, guys, that I forgot to give the projectile an initial velocity. So let's just say V initial is 25 meters per second. All right, so for part A, we want Vx and Vy. So what we have, guys, is 25 meters per second here as our initial velocity. If I decompose that vector into its horizontal and vertical components, we have Vx here, we have Vy initial here. This angle is 30 degrees. Recalling the SOHCAHTOA, recall, guys, that for the horizontal portion, we will use cosine, and for the vertical portion, we will use sine. So, that being said, Vx will be 25 cosine of 30. That gets me 21.65 meters per second. And Vy is going to be 25 sine of 30, which is just 12.5. So for part A, our values, 12.5 for Vy, 21.65 for Vx. Now, to get total time of flight for part B, again, before I do anything else, guys, I'll make a chart so that I can stay organized. Horizontally, we have Vx, dx, and t. Vertically, we have V final, V initial, acceleration, displacement, and time. So horizontally, guys, I have 21.65 here. Vertically, I have 12.5. Acceleration is negative 9.8. The displacement, guys, recall, displacement is a vector. It has a magnitude and a direction. Displacement only cares about 2 points, where you start and where you end in the direction that you're talking about. We're talking about vertical displacement, so the projectile starts at a height of 25 meters, ends at 0, and displacement is final position minus initial position, so 0 minus 25 means that the projectile fell negative 25 meters. Okay. We are looking for time. So given the information that I have 2 options. I could use, so we'll say method 1. I could use the second equation. Okay. With this equation, because initial velocity is not 0, I have to use quadratic formula or polyroot finder on your calculator, etc. This method is okay, perfectly reasonable. The other method is to use this equation, the VF squared equation, to get VF, and then use to find time. Okay. The reason I like method 2 better is I have to have VF vertically to find impact velocity. So I like method 2 a little bit better just because it gets me additional information I'm going to need anyways. So that being said, let's start with method 2. So we will start with our equation. VF squared equals VO squared plus 2AD. Let's solve. VF is plus minus square root v0 squared plus 2ad. Be very careful. The projectile, as it goes through the air, when it impacts the ground here, its velocity vertically when it is impacting the ground is going to be negative. So as far as signs are concerned, we must choose our negative value here. So let's plug numbers in. VF is negative square root of 12.5 squared plus 2 times negative 9.8 times negative 25. So I get here 25.42 meters per second as V final. So this is negative 25.42. And so that is this portion. Then what I will do, guys, is use the first equation, which says V final equals V initial plus acceleration times time. Solve this for time. Plug our numbers in. So that's minus 25.42 minus, I believe it was 12.5. Divided by 9.8, which is negative. Giving us 3.86 seconds here. This is the total time of flight. The beauty of this, guys, is because I've made a chart here, this is 3.86 seconds. And the vertical and horizontal motions are connected together, so this is also 3.86 seconds. Brings me to part C, which is horizontal range. So in the x direction, the only equations I have are Vx equals dx divided by time because there's no acceleration. So dx is going to be Vx times t. So dx is going to be the horizontal velocity, which is 21.65, times our time of 3.86 seconds. Giving us 83.77 meters. All right. Part D is maximum height. So let's go back to our picture. The maximum height of the projectile is going to occur somewhere here. Forgive me, I didn't draw the parabola very well. But we are looking for this height here, which is going to be some height above 25 meters. So I'll redraw the picture a little bit down here. So basically, guys, here's our cliff, here's our ball. It's shot like this. The motion is much more like that. Here is max height. So we are looking for this value here. Keep in mind, guys, that we're measuring this value from the ground, so we need to recall that the height of the cliff is 25 meters, and not forget about that as we work through this problem. So let's list out our vertical stuff just to remind ourselves. It's in the chart above, but we'll relist it. So initial velocity is 12.5 meters per second. In the y direction, acceleration is negative 9.8. Displacement is a vector. It's final position minus initial position. So d final is what I want minus where I start, which is 25. The time I don't know. I know the total time of flight, but I don't know how long it takes to get to max height, so I'm not going to worry about that. But I do know Vy at the top is 0 because the thing stops moving. So based on this information, guys, I can use my VF squared equation. So let's plug that in and see what we get. So we have VF squared equals VO squared plus 2AD. So displacement, VF squared minus VO squared over 2A. So that is going to be 0 squared minus 12.5 squared over 2 times negative 9.8. Giving us 7.97 meters. All right, from here, guys, what we've just found is the displacement above where we started. So this is the D that we have found. So what we need to do is add to that our initial height of 25 meters. Okay, so if we say that D is D final minus 25, we get that the D final is D plus 25, giving us 7.97 plus 25. So that is 32.97 meters for max height. Okay. Part E of our problem is impact velocity. So for impact velocity, guys, when the projectile hits, there is an X velocity, there is a Vy final, there is impact velocity, and there's theta. So Vx, guys, is 21.65. The final Y velocity we found is minus 25.42. Okay, so given this information, impact velocity is found by doing Pythagorean theorem. So that is going to be 21.65 squared plus 25.42 squared, giving us right, and that gives us 33.4 meters per second. Theta is found using tangent inverse, which is going to be 25.42 over 21.65. Giving us 49.5 degrees south of east, or below the positive x-axis. So, hope that's helpful, guys. Thanks.